All right, guys. If you weren't here yesterday, I feel really bad for you because that's a bad day to miss. But who didn't get yesterday's handouts? Anybody? Everybody got yesterday's handouts? That is a video you want to watch for sure. Not just because it's riveting. All right. Okay, let's do this. Let's do a couple. Let's do several problems to remember. Okay. So if I want you to use that z-score chart, what do you have to know before you can use it? I love you guys. What kind of distribution can I use? Normal. That's the number one thing you got to know. Now all the other shit is, can you make a z-score? Then that's like, well then, before you use a z-score chart, you probably. But before you can use it to make z-scores into areas and probabilities, you have to know that it's normal or normal enough. Today's going to be our first step into, here's a situation that isn't normal. What can I do, or what kind of process do we use, not to make it normal, but so I can check to see if it becomes normal enough. So we're going to get into that. Okay. Let's just make sure we remember what we did yesterday. So if I have a normal distribution, and let's say the mean is 108, and the standard deviation is 14.9. Just to be difficult. And then I ask you this question: what's the probability that I get a score? Let's say this is some kind of standard test or whatever. I get somebody who scored above an 80. You draw the picture for me. Draw the picture. Eventually, but right now I just want you to draw the picture. I have had people that just could not do this shape to save their lives, so let them do a triangle. I mean, it's just, really, what's that shape for us? Just an anchor place, just to put stuff, so we can visualize what's going on. So hopefully most of us are able to do this. Right? So what goes in the middle?
108.
Yeah, 108. What else do I want to put up there? 80. All right, so just put it down here somewhere, obviously, hopefully, obviously. I still love the people that just sort of put it wherever they want to.
I like it over there.
No. And then where do I shade? Got a few people pointing the wrong way. Greater than, so up here. So you know already it's going to be more than 50%. You can at least tell that if you draw the picture correctly. So if you forget to do 1 minus, which you're going to have to do, why am I going to have to do 1 minus eventually? Because the chart tells you areas below. I'm not talking to those of you that like the shortcut. I can do that. It's fine. Now what do I do? Get a z-score. I like it. Because again, that chart is just waiting to give me all the answers to any normal distribution probability problem in the universe. But I have to know z-scores to use it. I don't have a clue about freaking 80. That's a score on some standardized test. I got to convert that to a z-score. So how do I do that? What's the formula?
X minus U.
U's always second. If you switch those, you're going to be in the wrong place. You're going to get the wrong probability. This z-score should come out negative or positive? Negative, because it's down there. So if I plug this stuff in, what do I put here?
80.
80 minus 108 divided by 14.9. Jeff. Oh, it's like negative 1.93.
Negative 1.87.
That's close. Well, negative 1.87.
9.
So 88. From that probability quiz, I see a lot of you guys need to practice rounding. You don't just chop it. 03789. That's about 03789. Number 8. All right. So round those z-scores. Why do I round it to 2 places? Because our chart goes 2 places. Yeah, right? Chart only goes 2 places. Now try to look that up on the chart. See what you get. Yeah, so if you look up negative 1.88, you get 10301. Is that convinced? All right? Those of you that are looking at me like this, and then you don't ask any questions, I'm always like, what's happening over there? What's going on? So one of you knows what I'm talking about. Okay. 0.0301. Is everybody able to find that 0.0301? Okay, great. So where's that go? If you say it goes up here, that 3% is this. What? So it's always, the minute you look something up on the chart, you indicate it on your picture below what you just looked up. We just looked up the z-score for 80. Therefore, that must be there. So what's the answer? Sweet. And of course, some of you guys looked up positive 1.88 and got there quicker. That's good for you. All right. So here, you guys do these. Same distribution, right? What you got, Jeff? I don't know, man. Yeah, let's do this. Oh yeah, have fun with that one. Sorry. So those over there, try those out. Yeah, this is the same problem. Yeah, this is number 1 for this problem, number 2, 3 for this problem. I like it. All right, let me catch up to you guys a little bit. What are you getting for that z-score for 121?
27.
Yeah. What about for 150? 2.82. I like it. They're all fancy smashy. The better you make your picture and the more you use it, the nicer you are to yourself. So when you look up 2.82, what do you guys get? 9976, I like it. So that's from there all the way down, infinitely forever. And then if you look up 0.87, what do you get? 8078? Is that right? What you said?
Yeah.
So how do I get the area that I want? Subtract those two, I love it. So then this would be 0.9976 minus 0.8078. And that is 0.1898. Look at Jeff subtract. It's amazing. Okay. Keep going. This one's going to be, if I did it right, that one, the next one should be a little freaky. Chart tells you something that's kind of bogus. We'll get into it. All right, so have you guys gotten to the weird part yet?
Okay, there's no negative.
Okay, I like it. So the z-score, 30 minus 108 divided by 14.9. What do you guys get for that?
Negative 5.23.
Negative 5.23. Are you to the point yet where that is an immediate, like, red flag in a way? That's a huge Z. That's 5 steps away. The standard deviation is how far on average the data points get. I just took 5 of those steps. I basically have passed all the frickin' data. Right? The book said, the chart says 0.0001 for everything negative 3.5 and further out. But once you're at negative 5, screw it. It's basically 0. So you could either say 0.0001, which is because it's in on the chart, right? But more appropriately, it's about 0%. It's not really 0.0001. It's more like 0.000023, whatever, right?
So you'll take either.
So what's that? Yeah, I'll take either one. This one's slightly more correct, but this one's on the chart, which I'm making you use, so I can't not take it.
So how would you find the like percentage without the chart?
Oh, you'd have to use technology. Yeah. So I understand, the chart goes to only 2 places for z-scores, right? So it skips a lot of things, so it's not as precise, but I still think using the chart, you get a better feel for things and you learn more than just... So yeah, technology will always give you exactly the right answer. And you're going to need that if you're building a bridge or trying to develop a new way to save somebody's life from a heart attack or something. You're going to need that. Here we're learning ideas. So I can let go of being exactly right in favor of getting a better feel for things. Does any of that stuff make sense? I mean, so they sort of, at negative 3.5, I agree with them. And then, not too far below that, it's still basically this. But once you're at negative 5, 5 steps down, screw it, man. You ain't got nobody down there. This is like finding somebody who's less than 1.5 feet tall. I don't know. What's the shortest dude ever? I don't know. We gotta look that up now. Yes?
And what would we do for the deposit?
Sort of the same thing. If it was like, so if I would have said less than something way up here, then you would have, when you look at positive 3.5, what's it say? 0.999999999, right? Yeah. Then you would have said 0.9999 or approximately 100%. It's like saying what percentage of humans are less than 9 feet tall? 100%. Shit. Theoretically, it'd be 0.9999, but we know it's freaking 100%. Once you get that far off, it's going to be basically 100 or basically 0. What if I would have said greater than here? What percentage of the data is bigger than this? 9999, or basically 100% of it? What percentage of people are taller than a foot? No, you're going to say people, you're like, a little baby, not taller than a foot, Jeff. What percentage of adults are taller than a foot tall? Yeah, so basically 100%. I like it. Yes, no, maybe? Maybe. So that, when it goes off the chart, technically it really should be approximately 0% or approximately 100%. One of those two. But if you give me 0.0001 or 0.9, I'm fine with it. It's on the chart. That's fine. Okay. All right, so what about this question? Same setup. I'm at 4. Find P 29. And you're like, what is this? Pingo? P29. Pingo? What is P29? It's not a new exercise craze. Huh? 29th percentile. What does it look like? What does it look like visually? Where's it going to be? Yeah, because the mean is 50th percentile, so it's got to be here. Where's 0.29 go? Why? If you put it there, why is that bad? Why is that bad to put that there?
It's a Z-score.
Now it looks like that's where z-scores go. Is that a z-score? Oh, hell no, it's a percentage. So I'm looking for the z-score. So I'm given a percentage. I got to look up the z-score. So take a minute and see if you can find it. Somebody's already said something. Let's see if we all agree. Ooh, this is a good one. I like it. It's all about which one is closer. Closer. Closer.
Is it a negative number?
Yep.
7.22.
Who to what? No. Well, gotta look at your chart.
Oh, yeah, I mean,
Yeah, so one option is 2912 and the other option is 2877. Which one's closer to 29? You see how the 2912 is 12 above and the 77 is 23 below? So the 2912 is closer. What z-score is 2912 related to? Negative 5.5. I like it. Point that. So this z-score is negative 0.55. Why is that not really answering my question yet? What's the situation I gave you? Test scores, right? Is that a test score? If you told somebody you got a negative 0.55 on the test, it's like, did you run your teacher over? What'd you do? Why did he give you a negative score? You pissed them off. So this is not a test score. How do I make this into a test score?
Look at everything inside.
oh, just
Yeah, this is the formula I use if I know the test score. So I use the backwards one if I know the z-score instead. Right? So that formula, these are the same formula. Do you understand what I mean when I say that? Some of you guys are like, these office meds. But these are the same formula. One solved for z, one solved for x. They both convert between z and x. So if I'm trying to convert to x, I probably want to use the one that's already solved for x. So what do I put in here?
108.
108?
Negative 0.5.
Yeah, minus 0.55 of these. Say it's roughly 101.5. Maybe
99.
less than that. What is it?
99.805.
99.805. Okay.
So to find the z-score, do you plug in the percentage right there, the 0.29 into the formula?
No formula for that. There is no formula to go from a z-score to a percentage that we use.
Okay, yeah.
If you know calculus, there is, but we have a chart that does that. So remember this thing I showed you. I never know if this is any use at all. From here to here, there's a formula. And from here to here, there's a chart. So they give me a percentage, I use the chart to get back to the z-score, and then I use the formula to get back to the x-score. If they give me a raw score and ask me about a probability of something, I make it a z-score, and then I look up the area, right? So it's one way or the other. I'm gonna find you. I'm gonna get you. Now that's gonna be my head. Okay. That's very colorful for me up there. Normally these are my colors. All right, let's take a break, and then we'll get into some new stuff. Come back at I don't know, 20 till. Come back at 10:40. 10:40.